Numerical investigation on vibrational characteristics of glass-reinforced polyester composite plate. Abstract: composite materials are increasingly used in aerospace, naval and high-performance civil engineering structures due to specific strength, stiffness, corrosion resistance, large fatigue life and stealth characteristics. The reinforcement of composites with industry-driven woven fiber materials lead to improved properties of composite structures in terms of acoustical, elastic, and thermal properties. Glass fibers are the most commonly used ones in low to medium performance composites because of their high tensile strength and low cost. In woven fiber composites, fibers are woven in both principal directions at right angles to each other, warp and fill directions. To better understand any structural vibration problem, the resonant frequencies of a structure need to be identified and quantified. Today, due to the advancement in computer-aided data acquisition systems and instrumentation, experimental modal analysis has become an extremely important tool in the hands of an experimentalist. So, the modal analysis of laminated composite plates is of tremendous importance to predict the dynamic behavior of structures. Keywords: composite, glass fiber, modal analysis, vibration. Introduction. Glass fibers were prepared using melt spinning technique. These involve melting the glass composition into platinum crown, which has small holes for flow of molten glass. Continuous fibers can be drawn out through the holes and wound into spindles, while the woven fibers were produced by close arrangements of long fibers similar to the arrangement of thread in clothes. Based on their arrangement, they may be classified as unidirectional and bidirectional fibers. Fiber dimensions and to some extent properties can be controlled. Process variables such as melt's temperature and spinning rate. Glass fiber reinforced with resin always possess varying properties with the variation in the direction of ply, orientation of ply and number of ply. The different types of glass fibers used based on their mixture of various materials are as follows. A glass, soda lime silicate glasses were used for higher strength, durability, and good electrical resistivity as compared to other glass fiber types. C glass, in the high corrosive environments, calcium borosilicate glasses used because of its higher chemical stability. D glass borosilicate glasses with a low dielectric constant where mainly finds the applications in electrical fields. E glass, alumina calcium borosilicate glasses possess maximum alkali content used as general-purpose fibers where strength and high electrical resistivity are required. ECR glass, calcium aluminosilicate glasses with a maximum alkali content used where strength, electrical resistivity, and acid corrosion resistance are required. The main objective of this research work is to study and compare numerical result, deflection and natural frequency, on the glass-reinforced polyester composite plates. The different ply and different support is given to the composite model for analysis the vibration behavior of the plate. The best construction of the glass fiber reinforced with polyester resin composite plate was found by comparing the results of the composite plate. Different length and birth ratio is taken for another parameter in this project. The prediction of dynamic behavior of laminated composite plates plays a significant role in the future applications of structural composites. The check influence of glass fiber percentage on the mechanical properties such as tensile strength and Poisson ratio were investigated. These composite plates possess high strength-to-weight ratio which can be used in wings of high-speed aircraft, rockets and other related space vehicles. Problem with composite material. There are several inherent difficulties in detecting damage in composite materials as opposed to traditional engineering such as plastics. One reason is due to its non-homogeneity tie and anisotropy. Most metals and plastics are formed by one type of uniformly isotropic material with very well-known properties. On the other hand, composite material can have a widely varying set of material properties based on the chosen fibers, matrix, and manufacturing process. This makes model composite complex and often a mix between materials with widely differing properties. The most difficult is the damage in composite material often occurs below the surface, which further prevents the implementation of several detection methods. The importance of damage detection for composite structures is often emphasized over that of metallic or plastic structures because of their load-bearing requirements. The analysis of vibration monitoring data to monitor the characteristic changes in rotating machinery caused by imbalance, misalignment, bent shaft, mechanical looseness, faults in gear drives, defects in rolling element bearings and defects in sleeve bearings. Vibration analysis used to detect early precursors to machine failure, allowing machinery to repaired or replaced before an expensive failure occurs. 2. Methodology. 3. Material selection. Mechanical properties. Poisson ratio. The characteristics of fiberglass composite plate which can be determined completely by four material constants, E1, E2, G12, and U12 where the suffixes 1 and 2 indicate principal material directions. For material characterization of composites, laminate having different layers was manufactured to evaluate the material constants. The dimension of the specimen was taken as specified in ASTM D638 is represented in Table 3.1 below. Properties of glass reinforced polyester. The mechanical properties of polyester composite plate are given below. 4. Modeling of composite plate. The below figure shows the composite plate with different aspect ratios. Results and discussion. Modal analysis. Natural frequencies of the composite plate of 5-ply composite plate with aspect ratio of 1:1 and 2:1 are calculated using numerical analysis and SI. From Table 5.2, for L/B ratio 1:1 and 2:1 minimum frequency occurs at all sides simply supported, and for L/B ratio 1:1 maximum frequency occurs in 3 side cantilever and 1 side fixed, and for L/B ratio 2:1 maximum frequency occurs in 1 side cantilever support and 3 side fixed support. From Table 5.3, for L/B ratio 1:1 and 2:1 minimum frequency occurs at all sides simply supported, and for L/B ratio 1:1 maximum frequency occurs in 3 side cantilever and 1 side fixed, and for L/B ratio 2:1 maximum frequency occurs in 1 side cantilever support and 3 side fixed support. Glass reinforced polyester composite plate with varying number of plies and different length to width ratio were numerically analyzed and compared. The effect of different parameter like number of layers, aspect ratio, and boundary conditions including cantilever, simply supported and fully clamped was investigated. For simply supported boundary there is decrease in natural frequency as well as deformation with increase in number of plies. Thus, the dynamic behavior of the composite plate is greatly influenced by the number of the composite layers. There is 5 to 10% of reduction in natural frequencies in between 5 plies and 10 plies model. This natural frequency is used to determine the frequency at which resonance occurs.